I'm very glad that I can be here again. This is my third time to join this TEAC conference. It is my great pleasure to talk about the recent situation on the molten salt activity in Japan. I'd like to say also thank you again that all of you always think about the Japanese very hard situation caused by the huge earthquake. Not only the earthquake, but also the tsunami, which we get last year during the March. Japan is now getting back to the previous position. Of course, there are still several problems, but we are having a hope in order to look for the future. But when I talk about the nuclear power, the situation is drastically changed before Fukushima and after Fukushima. Of course, the safety is a very, very important issue. And we are now having the 50 available nuclear power plants, but all of them are under shutdown. And there are discussions to restart some of the, confirmed reactors in view of the safety will be restarted, but it is not yet decided. Maybe within a week or 2 weeks, it will be decided by Japanese government. In addition to that, there are other discussions that the people thinking, is there any other types of nuclear power plants which having a much safer characteristics? We do not think about this point, but as far as we use nuclear power for the electricity generation, the problem or the subject is a spent nuclear fuel. And if we use a uranium fuel, we becomes to have, of course, the radioactive waste, including the plutonium. For the case of using the thorium, the production amount of the plutonium becomes of course, smaller than uranium fuel, but anyway, we have fission product and so on. So what we have to think about to take care of the spent nuclear fuel is the incineration of these radioactive materials. And also, if we continue to use the nuclear power, we will be able to reduce production amount of the radioactive waste. So in this context, the thorium molten salt reactor becomes to be discussed in Japan. These are the books which I wrote in Japan. I'm sorry, only in Japanese, so I wish that you can read Japanese. I wrote this book before Fukushima, and at that time, not many people pay attention on the thorium nuclear power. But after Fukushima, these are not my book, but these are the very famous economic journals, magazines, which is very well known by the businessmen. And but the direction of each journal is very different. The upper part is named the Toyo Keizai, but this journal focused on the anti-nuclear, but they featured me. And they explain what is a thorium molten salt reactor and what is the difference from the existing, the light water reactors. But the lower one is also completely different. They wanted to promote the nuclear power, but they also featured a thorium molten salt reactor. And after these journals are published, I also wrote another book, and this book was published on just 1 year after the Fukushima accident. And I also featured in the TV program, the radio program in Japan. And Japan is, the western part and the eastern part. One of the most famous city in western part is Osaka, and that is my hometown. And this, the left-hand side is a TV program which is popular in Osaka city. And to tell the truth, this theme of the TV show is renewable energies, or I should say anti-nuclear. But I was also featured in this show. And I am the only man who talk about the nuclear power. And the right-hand side is a radio show, which is broadcasting to Tokyo areas. And this man is named Kaoru Takeuchi. He is one of the famous science columnists. And he also have a comment on the NHK. This is a Japan broadcasting companies. And he wrote some brief recommendation of my book in also the famous Japanese newspaper, which name is Nikkei. And I also featured other TV program. But the background of this TV program is a little bit sad. Just one day before I was invited to this TV show, there was a suicide in Japan. I cannot talk in detail about this suicide, but the man, when he retired in the, March from the Niigata prefecture, there was a small amount of thorium in his bag. And after he retired from the Niigata prefecture, he found that in his house there is a thorium. And last year there was several discussion about the thorium. And some people say that thorium is very good, but there are other people, thorium is very dangerous because this is a radioactive materials. And of course, ordinary people do not know what is thorium. So this man thought that, I'm doing very bad thing. How can I do? And he suicide, but with his wife. I was very sad. So when I was invited to this TV show, I carefully explained to the people, thorium is, of course, this is a radioactive materials. If we do not take care of handling this material, it will be able to cause some health damage. But if we understand what is thorium, we don't have to we don't have to suicide. And also informed that the thorium will be available for the nuclear fuel, and it will be provided not only in Japan but also in the world. Two, the invited lectures, which was held in this March, just 3 months ago. And the left-hand side was a lecture held by Hyogo Prefecture. This is one of the public one. And the right-hand side is a lecture which was organized by the Shizuoka Prefecture. Shizuoka Prefecture is a very important prefecture in Japan because within this prefecture, there is a nuclear power plant, which name is the Hamaoka. This is owned by Tube electric power companies. And the reason why this prefecture or the Hamaoka nuclear power plant is important is that this area is the heart of the next huge earthquake. Talking here is Mr. Kawakatsu, the governor of Shizuoka Prefecture. And after the Fukushima accident, he begins to think about how they can take care of the Hamaoka nuclear power plant. And he becomes to know about the thorium molten salt reactor, and he studied about its safety issues, and also he becomes to know that the thorium molten salt reactor is available to incinerate the existing spent nuclear fuel. And then he decided to invited me to make some lecture about the thorium molten salt reactors. Local government congress of the Kyoto City. Kyoto City is where I'm living now and where I'm working. And the Kyoto City has a university which name is Kyoto University. This is the home ground of Japanese activity to make research of thorium and molten salt reactors. This is a man whose name is Mr. Akio Kobayashi. he brought a question to the local government. How do you think about the thorium molten salt reactors for providing local electricity within Kyoto city? The mayor of Kyoto, whose name is Mr. Kadokawa, he answered that, of course, we understand the thorium molten salt reactor is available, but it is under still R&D phase. So the Kyoto city cannot say or cannot make any commitment, for example, to promote the research and development, but they carefully watch the progress of the R&D of thorium molten salt reactors. The government, Japanese government, did not lots of or large attention to the thorium molten salt reactor, but just before I come to this meeting, on 18th May, so just 2 weeks ago, one of the senators phoned me, and he said that he want to have some lecture about the thorium molten salt reactor. But their purpose is whether the thorium molten salt reactor is useful for incinerating the spent nuclear fuel. And the date is not yet fixed, but maybe when I go back to Japan, there will be some invitation, and the lecture will be held maybe within this June. What's the Tube Electric Power Company taking care of the next earthquake and tsunami at the Hamaoka nuclear power plant? If you look at this picture, you will see a huge wall here. And this is me. I was invited to this power plant just 2 weeks ago. They are now constructing the very huge walls in order to surround the nuclear power plant. Of course, the purpose is to protect the attack of the tsunami. And they also prepared a lot of additional power supply by the diesel engines. This is located within the reactor building, and they also prepared the smaller capacity of the diesel engine, but on the roof. So the height is higher than the 30 meters from the sea level. And they also prepared additional protecting panel around the sea pump. Can you see these numbers? This is a 15 meter from sea level, and this is a 20 meter from sea level. There are other heavy industry machines in order to open the ways when the earthquake breaks many things. And this is also the electricity generator, but this is a mobile or the transportable gas turbine generators. And what's surprising is this. This is a TV news. Okay. Did you see Hamaoka? Hamaoka is a Hamaoka nuclear power plant. This is a news which I saw yesterday. And what they say is that the Tube Electric Power Company decided to make a research center for the safety of the nuclear power plants. Just a pause. Would you please look at these 4 characters? These 4 characters pronounced corresponding to this character. This is thorium, corresponding to here. It's very interesting that the purpose of this research center includes the use of the thorium as a future fuel, and they also target to develop advanced nuclear reactors. But it includes the molten salt reactors. Could you hear the sound of thorium? If you go back to your hotel and room, and if you browse the name of the Chubu Electric Power Company and Research Center, you will find some English news from the Mainichi newspapers. Okay, these slides are introducing the recent situation about the thorium molten salt reactors in Japan. And I'd like to briefly mention about what I'm myself doing in Japan. What I'm doing is to develop a transportable, very small molten salt reactors. And the capacity of the, I'm going to produce electricity, but the capacity will be around 1 megawatt, 1 megawatt. And my design will be available a little bit larger capacity, but maybe up to 10 megawatts. And this is a thermal reactor and using a graphite moderator. And it is pointed out that as far as we use a graphite as a moderator in a reactor core, there may be a problem of the positive thermal coefficient, reactivity coefficient. But we are going to avoid this problem by using the small size reactor core and additional mechanical treatments. And this reactor does not achieve a large conversion ratio. And this will not be breeder reactors. Because I myself are carrying the other research on the ADS. And of course, this is not yet fixed. But it may be available to provide the fissile material, uranium-233, externally from the outside of these reactors. And I'm sorry, the details is still, how to say, the development. And my colleague in Japan have already finished to make a simulation of our reactor core. And he told me that it will be available to get some calculation result this June. In order to develop this kind of transportable small reactor, I organized some R&D team with my colleagues. And it was established 2 years ago from now. And in the beginning of our project, we tried to pick up the research team in order to make a transportable molten salt reactors. And last year, we could get a conceptual design of the transportable reactors. And from this year, we are now preparing the calculation code and so on. And this is just my wish. Maybe we would like to fix the specification of the prototype reactors. If it is available, we would like to fabricate the prototype reactor 2 years from now. And if it is possible, we would like to provide a commercial reactor from the 2020. But only God knows what will happen. The most important point is that the thorium itself does not have the fissionable isotope. Maybe 2 years ago, I showed this kind of pictures. The left-hand side indicates the uranium fuel cycle because uranium including the fissile isotope 235, it is available to be used as a nuclear fuel only by using the natural uranium. But for the case of the thorium fuel cycle, we do not have any fissile isotope from the natural resource, so we have to prepare by using the producer, ADS, something like that, or other possibility is that we can use the plutonium coming from the spent nuclear fuel of the uranium fuel cycle. We also have to evaluate, quantitative evaluations. This is a preliminary calculation which I did 2 years ago, but roughly the tendency does not change. today and yesterday. And if the capacity of the uranium fuel cycle increase like this until the 2050, maybe the uranium fuel cycle becomes 3 times larger than which we have today. But if we use the plutonium coming from the uranium fuel cycle, in this case, the capacity of the thorium molten salt reactor will reach only 400 gigawatt and so on. And because of the influence of the Fukushima Daiichi nuclear power plant accident, if the capacity of the uranium fuel cycle does not increase, of course, the available capacity of the thorium fuel cycle will be greatly reduced. So what we have to think about is how we can get additional fissile material. But the question can be modified. How we can get neutrons? In critical reactors, of course, in subcritical reactors, we use neutrons coming from the fission reactions. And of course, the fusion reaction will be available to get the neutrons. And of course, the spallation is very, very attractive. But also, the D-beryllium, deuterium-beryllium reaction will be available. But of course, people know that the efficiency of the deuterium-beryllium reaction is not so high compared to the spallation reaction. But anyway, the key is accelerator. In my study, we would like to provide the reliable and stable and efficient and of course the cheap accelerators. Okay, this is our proposal, which name is mid-use accelerator. And if you look at the in front of this room, you will see the 2 posters, and much detail is described here. Neutron providers. And what's interesting is that you will see there are many tubes. Each of them are independent accelerator tubes, and this provides the flat neutrons at the end of the each accelerator tube. And the other additional good point is that the neutron generation rate can be controlled by each accelerator tube, so that we can, control the spatial distribution of the neutron flux. This is one figure of the our preliminary design of the ADS by using the mid-use accelerator. Here, this is a pressurized PWR type reactor core, and from the left-hand side and the right-hand side, neutron will be induced to the PW core. Of course, we understand that there will be several the challenging in order to achieve this kind of design, because the neutron is induced externally from outside of the reactor vessel, so that we have to evaluate the effect of the neutron radiation damage and so on. And we are now constructing the factory at Fukushima, and which will be completed next year. And the first neutron will be available in 2014. And these are the schematic design of our new factories. This and this. This is an accommodation room, so if you want, you can come to our factory. And this accelerator will be, or maybe, available to put inside of the nuclear power plant. And the purpose is to incinerate the spent nuclear fuel. And if we put the thorium fuel here, it generates the uranium-233, and it can be fed for the thorium molten salt reactors. So that we are discussing whether this is available for Japanese electricity company, such as Chubu Electric companies. But of course, they will have several problems, so maybe it may be not so easy. And we have already published the paper this April, so if you want, you can find, or you can call me. And that is all. Thank you very much.
Thank you so much.
Thank you very much. Yeah.
We got time to take one or two questions.
Yes, I would like you to comment on the effect of shutting all the reactors down in Japan. I was thinking that would be a big problem.
Your thoughts about shutting all the reactors down in Japan?
Of course, I wish that the available nuclear power plant, which using the light water reactor, should be restarted. But anyway, the Japanese people do not want to continue to use the nuclear power plant, so the capacity of the light water reactor may be gradually reduced. But if we can develop the thorium molten salt reactor, but it may take more than 10 years or 50 years. In the middle of the 2020, we may be able to provide the additional nuclear energy by using the thorium molten salt reactor. I wish so.
There's enough additional capacity that you don't need those reactors to shut it down. It's not a problem.
He's asking if there's enough power generation capacity in Japan, or what are you guys doing without so much?
What we are doing is to start the supplemental fire plant. But the fuel is natural gas. And I myself think that this is a very, very, dangerous. Because this supplemental fire plant is, reservation. So they are not considered to be operated in a full time and all day in a year. And also the price of the natural gas increases. And so I don't think it is a good decision. So we should rethink, maybe within this year and next year.
In your last slides, you had pictures of designs for Fukushima. The estimated time, when do you propose, is that a demonstration plan number one?
You mean I'm sorry, I cannot show, but the last slide before conclusion.
Right.
Yes, that is a conceptual, schematic diagram. And to tell the truth, we don't have any completed accelerator. And maybe it will be available 2 years from now. And before it is completed, we have to discuss with electric companies. And once we can get some agreement, it will be a demonstration plant. And as I introduced in my presentation, for the case of the Chubu Electric Power Company, they established a research center. So this is a kind of the research. So I think the demonstration will be available.
Very good. Let's thank Takashi again for, thank you.
Yeah,
Thank you so much.
Thank you very much.